Hey guys, my name is Matt and I love both cars and new technology. Recently I decided to replace my halogen headlight bulbs with LED retrofit bulbs. I discovered a whole new world. Automotive LEDs are designed according to specific and different standards, so you can see and be seen perfectly at night, like the Philips LED Retrofit. But what's an LED retrofit bulb? Well, to answer that question, let's give the floor to Mark Kessels. He's an expert in LED technology, and he will lead our way today.
An LED retrofit bulb is a lamp designed in such a way as to imitate a halogen bulb, and thus allows you to replace your halogen headlight bulbs. This upgrade offers better control of the light, an Arctic white light and a clean beam pattern that does not glare on oncoming drivers. Of course, even if LED retrofit bulbs somehow behave like halogen bulbs, they are not built the same way. Let's have a close look. An LED retrofit bulb contains, as its name already states, an LED. This is the light engine of the bulb. For our bulbs, such as the Philips Extreme Multilon, we are using Lumiled's automotive-grade LED chips, otherwise only available to car makers. It provides a bright and uniform beam in a cool white color temperature. The LED chip also provides excellent thermal performance in order to operate at high temperatures. Speaking of heat, this part is called the burner. Every source of light generates heat. Even though LED retrofit bulbs produce light more efficiently than halogen, they still produce heat. LEDs will live longer if they are working at lower temperatures. Therefore, it's important to move the heat away from the LED light engine as quickly as possible. And this is where the design of this burner comes in. It moves the heat away from the LEDs into the heatsink. A good burner uses materials with high thermal conductivity. The next mechanical part is the heatsink. Now the heat is moved away from the LED, but it still needs to be transferred to the ambient air. And this is done with a heatsink. Our LED retrofit bulbs feature Philips heat management systems, which can be passive or active. This Philips LED H7 is using an active fan-based cooling system. The heatsink is small and very powerful at the same time, and that will ensure a reliable lifetime. To switch the bulb on, we need some electrical components. This robust cable connects the bulb to the car electronics. It's highly reliable for enhanced safety and performance. Some bulbs also feature an external driver. This driver ensures a constant light output through the LED, because any slight variation in the current could result, for instance, in loss of brightness. The driver also powers the fan in the heatsink. Now we have a working bulb, so let's mount it in a headlamp. This part here is called decentering. It ensures the right positioning of the LED retrofit bulb within your headlamp. We want to make sure that the LEDs in the bulb are at the same position as where the filament is located in the halogen bulb. By turning the ring, we can make sure that the LEDs emit the light sideways so that we get the best performance on the road. And here it is.
Wow, I mean, so many components for a small device. It's fascinating, isn't it? Well, the Philips LED retrofit bulbs are also very robust. They can withstand severe vibrations and are EMC verified, meaning they won't suffer from any interferences of your car's other devices. I got one last question though. How does an LED retrofit bulb work? I mean, it's not a very hot wire, as in halogen bulbs.
LED stands for light emitting diode. It works thanks to an electrical reaction. And the key word is diode. It consists of two layers of semiconductor material made of indium gallium nitride. One semiconductor is doped with negative particles, providing electrons, and the other one with positive particles, holes, which absorb electrons. When connected to one another, they create an electrical diffusion layer where the positive holes absorb the negative electrons. When a hole merges with an electron, light is emitted. By attaching a battery to the LED, new electrons and holes are pushed into the diode, so we keep getting light out the diode. See? It's easy.
Even my physics teacher couldn't have done it better. Thanks, Mark, for everything. Thank you guys for watching. That's all for today, but we'll be back soon and ready to lead your way.
Innovation and you, Philips.